My name is Sean Higgins. I've always been interested in speed. The fastest known speed to man is the speed of light, which travels at almost 300,000 kilometers a second. Isaac Newton characterizes light as a particle. More than 200 years ago, another man came along, Thomas Young, and wanted to show that light behaved like a wave. And what has become known now as the double-slit wave particle experiment has been conducted in many different forms to show that light behaves like a wave. In this experiment, a metal plate has two slits cut in it fairly close together, and light is passed with a beam through the slit and picked up on the other side by photographic paper. Now, if it was to behave like a particle, imagine sand, which is what we understand as particles. Imagine sand being poured through a metal, flat piece of metal, through a hole. How would it form underneath? It would form in a cone to a point, a high point. So on the photographic paper, it would show darkness in the middle, descending to slightly lower shades either side, showing a particle type diagram. Now, if it was to behave like a wave, imagine a stone being thrown into water and it ripples. The ripples merge into one another, and at those points of merging, you would have the darker shade. So, Thomas Young set up his experiment, and he showed from the pattern that light was behaving as a wave. So he set up a monitor to see which way the light was passing through these slits. And an extraordinary thing happened. It was as though the light knew it was being watched. And when he turned on the monitor, the light behaved like a particle. And the pattern on the photographic paper showed the diagram as a particle. To this day, science, physicists do not know why this happens. The purpose of this video is to explain what happens, what is going on. This experiment has been conducted, as I said, in many different forms. Another form is the quantum eraser experiment. And in this particular form, the light is passed with a laser beam, photon by photon. And it is passed through a crystal to divide the beam into two beams. The first is picked up on the photographic paper, and the second beam is picked up on the photographic paper much further away. Both have a monitor put on them. So when you turn on the monitor to the first set, sure enough, the pattern changes from the wave-like pattern to the particle pattern, which physicists know as the interference pattern. Then again, when the monitor on the second set of photographic paper is turned on, the same thing happens. Again, the wave pattern changes into the particle pattern, the interference pattern. But something even more extraordinary happens. The first photographic paper goes back to the original wave pattern, even though the monitor is on. So, why does this happen? To this day, physicists do not know. This is a matter of time and motion. If the particle reaching the second photographic paper is altering the pattern on the first photographic paper after the light has already reached the first set, then it is not happening afterwards. It is happening before. And if it is happening before, it must be travelling faster than the speed of light. So the particle arriving at the second photographic paper is travelling faster than the speed of light. You want to cut and see what that is looking